This is just for the recording. Good afternoon. Sorry you couldn't be here today. What we're going to talk about a little bit today are the areas and zones of a lake. So right here you will see that one of the things you should know about a lake is how these different parts are defined from the shore out. So the littoral, limnetic, and profundo zones, you can find the information there on page 99 of your textbook. And then you should also pay attention to the stratification of a lake, which is the layering of a lake. And those are described by epilimnion, thermocline, and hypolimnion. And you can find that information on page 105 of your textbook. So here we have these different words for different parts of the lake. The littoral zone. What is the identifying feature of the littoral zone? It's next to shore, and it has plants that grow on the bottom. They have roots. So it's important to remember that in this particular zone, once the plants are no longer growing on the bottom, we have moved out of this zone. We are into the next zone. So let's go through the limnetic zone. What's kind of a unique feature of the limnetic zone? Go ahead. So the characteristic of the limnetic zone would be what? What do you see? We're still going to see sun there, so sun can get through, but there is plants, but they're more in the form of plankton. So in this one here, you will see things in the water for sure, but not rooted plants anymore. But you would see like algae floating around and then other little animals floating around and that sort of thing. So you certainly are going to have photosynthesis taking place in this zone, but kind of the predominant thing about it is that there would be plankton there. And then we get to the profundo zone, and this is the area of lakes where the light can no longer penetrate. The light waves have run out of energy and they can't make it down any further, so it would be extremely dark. And we were just discussing the fact that probably most eutrophic lakes don't have a very big profundo zone, if they have one even at all. And then we're going to go to the stratification here a minute. So here you've got your stratification of a lake, kind of the layering. What's the epilimnion layer characterized by? That would be a place where you would see a lot of life, but a lot of temperature change. Okay, so that's the part of your lake that's going to heat up and cool down a lot. That's the part you swim in, as an example, and you go in the morning and it's pretty cool, and you go in at night and it's probably quite a bit warmer, especially if it's been a nice warm day. So you're going to see quite a bit of temperature fluctuation in the epilimnion. How about the hypolimnion? Yeah, it's pretty much cold all the time, or cool, not much temperature change. And then what are you going to see in the thermocline? Yeah, so some fluctuation of temperature. So these words are just so that when you see them on tests or you're asked to talk about like spring or fall turnover, you will know what they mean and you'll know how to use them. So in this data here, you can see we're looking at the density of water, and you can see that water doesn't follow this pattern of normal liquid densities. And if you take a look here, here's kind of the magic one. Water is most dense at 4 degrees Celsius. And so you can take a look at your textbook, page 106, and you can read a little bit about that. The discussion we just finished in class was this discussion of how liquids their densities change with temperature. And so here's a graph kind of showing a typical liquid This graph is simply saying that as liquids warm up, they become less dense. And the biggest reason for that is because you have particles that are moving quicker, having more collisions, and spreading out. So you would actually have less particles in warm vegetable oil than cold vegetable oil, as an example. Next, you have a look at water. And water is a extremely unique liquid in the sense that its density doesn't quite follow the pattern that you would expect. Here you can see in this graph that water reaches its greatest density at about 4 degrees Celsius, and after that, in the 3 to 1 degree Celsius range, the density actually decreases again. You would expect that water would kind of follow that pattern, but it doesn't. And it's because of that property of water that lake turnover can happen. So below you see an explanation of the 4 seasons that you would expect lakes to go through and kind of what's happening at in each season. So we're going to begin with winter. We could start anywhere with any season, but we're just picking winter. In the winter time, you're going to see lakes in Alberta and in colder climates with ice on top, and that ice will prevent oxygen from getting into the water. It's going to block it out. We might have a little bit of sunlight getting through the ice, and if there are some plants that might still be living, we might get a little bit of photosynthesis happening. But by and large, the most important thing to remember is that in the winter, there's no oxygen really at all coming into lakes. And so lakes are basically holding their breath for 4 or 5 months. The oxygen that they have in the water needs to last for 4 or 5 months here in Alberta. Next, you have springtime. And in springtime, the ice will break up and the surfaces of the water will start to warm up. And you'll probably also have quite a bit of wind in the springtime. And the magic kind of happens when the surface of these lakes hit 4 degrees Celsius. And as you remember, water at 4 degrees Celsius is most dense. And when that hits that 4 degree number, that water will drop down into the hypolimnion area of the lake. And with it, it's going to take oxygen. And that is key to getting the oxygen down into the lake, and so that other things can use it, organisms and fish and all of that. The water at the bottom will rise to the surface, and then it will heat up to 4 degrees, and it will drop and bring oxygen. And so in the springtime, for a good maybe 2 or 3 weeks, or maybe even a month, this water is going to be churning and bringing oxygen and mixing it into the water throughout this lake. In the summertime, these lakes are pretty stable. They start to layer out based on the temperatures. Warm water would be, in this case, a little less dense than the cold water, and you will have just a really stable environment. The epilimnion area would continue to get oxygen because it's at the surface, and so waves and maybe even a motorboat would add oxygen, help oxygen get added to the surface. But by and large, the hypolimnion areas of these lakes really don't receive much oxygen. There's no turnover happening here. And when you start to get the plants dying toward the end of the growing season and then bacteria coming in, they're going to start decaying those plants, and they're going to use a lot of the oxygen. So maybe by the end of August, you're going to see some of these, the bottoms of the lakes in particular, really starting to be deprived of oxygen, and they're needing to get replenished in that area. So fall comes along, and the same thing in the spring as in the spring happens, except we call it now fall turnover, of course. And this is where these surfaces, the surface waters in this case, are cooling because it's getting colder outside. Eventually, the surfaces are going to hit 4 degrees Celsius, And then that water at the surface, that's at 4, is most dense, and it's going to drop to the bottom and bring the oxygen with it again. The bottom waters are going to come up to the top, get oxygen from the surface, and then bring it back down, and you'll have this continued moving and churning of water. And that, again, is probably happening right now in Alberta as the nights get cooler and we get lower surface temperatures. So that is kind of an explanation on spring and fall turnover. Density of water is key to understanding this.